Good morning, everyone. You can respond. I know you're a bunch of climate modelers, but you can respond. Good morning. Yes. So my superpower is, unlike all of you who are experts in something equally profound, I'm a generalist. I'm not afraid to stare behind many doors. So with my presentation today, I'll be giving insights into some of the work we've been doing looking at the 6 assessment reports produced by the IPCC over the last 8 years, and looking at what insights they might offer us as we have the discussion over the next couple of days about the climate information that's needed around data integration needs. Before I start, though, let me thank my colleagues, Marlies Craig, Michelle North, and Nina Hunter. They're all members of the Technical Support Unit of Working Group 2, based in the Durban office. They did the assessment which underlies this particular presentation. I'm not getting the slides to move on. Should I be pointing at you? Right. So, the 6 assessment cycle. The longest and the busiest in the IPCC's history. It's been 8 years, 6 reports and 1 synthesis report down. We've produced 3 special reports. I'm sure the majority of you will remember our special report on global warming of 1.5, which I think became really a turning point in the global conversation. We've produced the 3 global assessments, and just this year in March, we released the synthesis report, which pulls together some of the key messages from these 6 underlying reports. The one learning I take away from the 6 assessment cycle is I think this is the last assessment cycle that we as the scientific community can hold our hands over our hearts and say we fulfilled the IPCC mandate of producing a comprehensive assessment of the literature by traditional means. And why do I say that? It's simply because of the exponential growth in the literature that is available to us. If we reflect back into the dark mysteries of time when the IPCC produced its first assessment report, just over 1,000 publications available to that assessment team. By the time you get to AR6 and onward to AR7, we're now talking about hundreds of thousands of publications available. Unfortunately, no direct correlation at all between the papers you write and the action on the ground. If there were, we would have solved the climate crisis about 3 decades ago. It also doesn't mean that there aren't knowledge gaps that we have to address. And I think that's where the work of the IPCC is tremendously useful, because it allows us to understand across this broad landscape what we do know, but it also allows us to understand better what we don't know. And that's what the team went hunting for. They undertook a term search trying to capture this idea of data gaps in the underlying reports, and that search generated over 10,000 results. So a couple of thousand results in the main assessment reports and a couple of thousand across the 3 special reports, really indicating that despite this huge body of literature, despite the enormous amount of work being done by the IPCC, still a lot we don't know. And indeed, these in excess of 10,000 search results would be conservative, because it wouldn't have picked up data gaps triggered by statements like more research is needed. So if we look across the products, we can see data gaps identified in all of our key products. We can see data gaps in virtually every chapter, but varying levels of data gaps are recorded in each of the products and each of the chapters. We also see that they are organized in different ways. So we've got 44 chapters with distinct knowledge gap sections, which we used for the search. Then 30 chapters that didn't have knowledge gap sections, and so the team went in and looked at the executive summaries and sometimes went into the main body of the text itself. So what do we learn from the search? Starting off with some very high-level messages. Whoops. Let's go back. And these are not meant to be comprehensive, but they give us a sense of what the assessment teams were thinking about when they reviewed the literature, pointing to real concerns around availability and access of data, problems with data sharing, the very fact that Bjorn has been speaking about, but also cessation of data, where, for example, we have weather stations stopping work. We don't get data from those anymore. Also problems with rescue and curation of undigitized data. As someone with a foot in the policy and practice camp, I can't tell you how much data lurks in the bottom drawer of my office in local government. And that is repeated across the practitioner space. We've also got problems with scientific research capacity creating gaps, particularly in the global south. A lack of coordination where we are measuring. We're not using common methods or common indices. And unsurprisingly, the assessors identified imbalances in the knowledge gaps. So things like academic versus non-academic literature, global north versus global south, high impact versus low impact, and often insurmountable barriers created for those of us in the global south by the paywalls created for publications. But also identified within the context of the search were real spatial and temporal gaps in what we know about the world. Spatial gaps in the sense that data can be scarce across entire regions or entire typologies, so things like Central Africa or the deep oceans. Where we've got low data density, we get low model resolution. Challenges with downscaling, and this really creates consequences for forecasting both climate change and climate variability for small, topographically diverse regions like the islands or the cities. And this is going to pose a particular problem to the IPCC in the 7th assessment cycle, because the first product, likely out the gates, is going to be a special report on cities. What do you need? You need downscale data. Temporal gaps, particularly in the historical and prehistorical periods, so pre-satellite to paleoclimate, problems with proxy data, availability, but also the loss of natural archives. The consequence of these mass mortality events where we see forests dying, you lose your archives. It's clear from the work that the authors did that indigenous knowledge and local knowledge could be brought in to fill some of these gaps, but they're not being commonly used, which poses a real challenge. What really interested the team and interested me with my practitioner and policy hat on is the data and knowledge that are of interest to me. So that's policy relevant timescales. So that's decadal and shorter terms projections. So the 5 to 10 year period with climate variability mixed in is not given great emphasis. So the very things that the people who do in the world need is not identified as a priority in the mix. If we look at how the IPCC describes the landscape of risk, and this is a tool that binds the 3 working groups in various ways, we see risk from climate change as emerging from the interaction of hazards, and those are driven by changes in climate impact drivers, so the extremes and the means, interacting with vulnerability and exposure in human systems and in our natural ecosystems, but also importantly with our responses, our adaptation and mitigation responses. Working Group 2 particularly highlighted, for example, the emergence of maladaptation, the unintended consequences of our well-intentioned adaptation actions, in fact, increasing risk rather than reducing it. So if we look at the knowledge gaps identified across that landscape in AR6, obviously in terms of climate impact drivers, many of those changes are due to emissions. So no big surprise that we see the authors calling out the need for more information about all relevant emissions, not just some of them, more detail, more disaggregated information by sector, by product, by region, but also this breakdown between consumption and production. So currently cities are responsible for about 2/3 of emissions, but that's consumption and production based, and that has very important implications for policymakers. Also the need to think about embodied emissions, particularly important when we think about global trade with life cycle analyses, and negative emission sinks, particularly as we work towards net zero. When we look across issues of vulnerability and exposure, surprisingly, not many knowledge gaps identified there, but bear in mind that knowledge and vulnerability and exposure are really brought into the assessment of impacts and risks in many ways. Where gaps are identified, they are identified for sectors and for systems. So in the natural system, gaps around things like biodiversity, around range shifts in response to climate change. In social systems, things like migration and displacement and poverty. Important for the policy space, we still have significant knowledge gaps around losses and damages, irreversible impacts and losses, and these becoming increasingly important if we look to the UNFCCC and what has been discussed there, financing, for example, around losses and damages. And certain topics, particularly those called out by Working Group 2, around equity and justice and culture and well-being as key determinants of our vulnerability and exposure, are places where we need more information and knowledge. Ironically, we find ourselves in the decade of action. Where do we have our biggest knowledge gaps in terms of responses? So those are in terms of the potential of adaptation and mitigation, In terms of feasibility of these options in different contexts, because remember, what works in place A is not necessarily going to work in place B. Their effectiveness, monitoring and evaluation. So we are working, but we're not looking at the outcomes of our current actions. Are we hitting the mark? Aren't we? What is the impact of climate change impacts on adaptation and mitigation interventions and their ultimate effectiveness? A very strong narrative that emerges from working groups 2 and 3 is this need for transformative change. But again, key knowledge and data gaps linked to key components of this. Working group 2 articulates that transformative change needs to be driven by system transitions, by transformative adaptation, by this thing we call climate resilient development, which draws adaptation, mitigation together with a view to achieving sustainable development. Working group 3, gaps around deep decarbonization, net zero. We also need more information on the catalysts of change. What does it take to actually motivate society to make these transformative changes? And particularly important for policymakers and practitioners, case studies. So we can see how this works in the real world, that we lift it off the page into reality. Also big gaps around the enablers of adaptation and mitigation. Systems of governance, financing, and investment are all places we've got big gaps. If we look to the climate models, all 3 working groups identify knowledge gaps across the broad spectrum of climate models. Unsurprisingly, working group 1 calls out the need for more detail around emissions, but also water cycle and land processes, so teleconnections that exist between systems, the impact of land use changes. In the ocean and cryosphere, more knowledge about the currents, more knowledge about the glaciers and the ice sheets are needed. But importantly, working group 1 also highlights the need to think about the gaps related to feedbacks. So the thawing of the permafrost, where we see carbon sinks becoming carbon sources. Working group 2 has a more idiosyncratic relationship with models, but we also call out gaps in relation to the models. The fact that the current models don't reflect the full cost of climate change. They don't adequately represent the tipping points we're calling out, or the limits to adaptation, which are becoming so clear. We also need a better reflection of complexity, so incorporating socioeconomic factors like poverty and vulnerability, compound risks, where many risks occur together, and the fact that we are acting. What are the impacts of our policies on things like water availability? Gaps related to economic modeling methods, the extent and timing of residual risks, the risks to ecosystems, particularly marine and coastal, which are becoming a focus in the policy debate. Scale, again, this need for downscaled models to draw into our assessments at a more granular level, and the effectiveness of tools which are being looked at increasingly, so ecosystem-based adaptation and nature-based solutions. Working group 3, also gaps around emissions, unsurprisingly, but also an indication that modeling of certain components is still in its infancy. So things like demand-side management, we don't have a really granular representation of options in the models. Some components like industry are weakly represented. Social aspects like inequality and welfare need to be brought in more strongly. The impact of climate damages on different sectors, the impact of climate policies and their implementation. Again, this focus on equity and fairness is something that's really missing, and the need to look at other disturbances with feedback such as pollution. Those are the views of the separate working groups, but the one clarion call across the 3 working groups is the need for much more urgent information on complexities and interactions, the way these things interact with one another. So the complex interactions across that risk landscape between the various components of the propeller diagram, both within the propeller elements and between them. Compound risks, where we've got more than one risk at the same time. Cascading risks, where climate and non-climatic drivers interact with one another. Cross-sectoral linkages, particularly we've got a nexus between land and water and food, for example, and feedbacks within these systems. Complex problems generate the need for integrated responses, but again, data and knowledge gaps called out here, particularly those responses that address more than one goal. And this is challenging if we think about this concept of climate resilient development, where we've got to draw together adaptation, mitigation, and a view to achieve sustainable development. Bringing together the idea of sufficiency and degrowth, looking for these synergies and trade-offs in our actions. All of these require cross-sectoral approaches and definitely require non-siloized research. A big challenge is, what are the brand we're selling? Or what is the key brand we're selling to our policymakers and practitioners? This idea of a best possible future. If they act, they can achieve a better world, a world of well-being, low poverty, low global warming levels, low risk. The problem is we lack data and information about key components of this world, around net zero, deep mitigation, around transformation, and the key system transitions to drive it. Resilience, these thorny issues of equity and justice, economic issues, how do we decouple our economic system from fossil fuels, emerging technologies, and importantly, those case studies that allow policymakers to see and understand what this transformative change might look like. So we've got big questions around what does it look like and how do we get there still. We've also got gaps around this increasingly humanized face within the climate system, this golden thread that runs through it, the understanding that we as a society are a major game player around our individual emissions, our levels of consumption and demand and how they vary, the impact of climate change on our health, the need to draw in development discussions, people as agents of change, social networking, and exactly what impact do just transitions have on the economy and on the labor sector. Also key gaps around enablers of change, finance. We've got a particularly large hole in our knowledge around adaptation finance, and we've heard a lot over the last couple of weeks about the need to remodel the global economic system to enable action, around the different forms of governance that are necessary, around technology development and sharing and capacity development, and this use of indigenous and local knowledge. How do we draw that into something like EVE? So the summary from the IPCC is, what do we learn in identifying these knowledge gaps? Well, it's very clear we need more fundamental basic data, particularly for certain regions or systems, that's clear. We need models that can handle complexity, particularly these social aspects, which are becoming so important in us understanding how we might move forward in terms of response. We need more literature dealing with these complexities, the interactions, the cross-sectoral impacts, the systems approaches. We need to better monitor and evaluate what it is that we're doing, and we need a better balanced literature that draws in a broader range of knowledges. And I think EVE might be able to contribute at a number of levels in terms of filling those gaps. But for my last slide, I want to take off the hat as an IPCC co-chair and step into the real world as a practitioner. And as a practitioner, I certainly laud the EVE initiative. I mean, there's a great deal to be achieved by better understanding the climate system, by developing more granularity. But it's simply not a case of more climate information and ultra-high resolution data. In the world of policy and practice, there are no silver bullets. And I can tell you climate data are only a part of what drives decision making, and on some days, a really tiny, tiny, tiny part. We have to see, I think, ultra-resolution or high-resolution data as a tool in a much bigger toolbox within a hierarchy of models, using it with a broad range of other tools that link into the real-world politics that we're dealing with. We fundamentally need to meet people's basic needs. So today is the start of a conversation, but you need to meet me in my municipal office. You need to talk to me in my role as a practitioner, because I can guarantee you will find very different feedbacks in that world than you will in a world like this. We also need to be careful of resolution versus uncertainty. Policymakers love higher resolution data because we think it will predict our future, so we can make really concrete decisions. But when it comes with high uncertainty, I've seen that break the trust between the world of science and policy, so be cautious where you venture. You also need to look at the unintended consequences. That's what we learned in Working Group 2. Look at every action and see what your unintended consequences might be. So if we harness these huge computers we're talking about today, what are the consequences of having that computational strength going towards EVE and not other initiatives? What energy might we be consuming? And the important thing as a practitioner is I need action now. In fact, I needed action yesterday. And so we need to be able to balance the research and operational needs. And probably the most important thing is to recognize is we actually currently know enough to act at this point in time. So we need to bear that in the back of our mind. Thank you very much.